In this question here, we're just going to have a look at locating and finding the dihedral angle between two planes. So in this question, we're given a plane ABC and a plane ABD. So here we have both the elevation and plan of those planes mapped out. So it's both of them are planes that have 3 points. Okay, so ABC, ABD, obviously the same line that's in them is AB. We can see that as well from the drawing that the common line on those planes we have AB. Okay, so AB is a line shared by both planes, or AB is my line of intersection between those two planes. So that's the first thing I have to do when I want to locate and show the dihedral angle. I need to find and establish the line of intersection. Okay, when I have it found, I always put that in as red. So my line AB is my line of intersection. So I'm just going to highlight that there in red in both views. So put in my line of intersection, I put it in clear in red. So that's my line of intersection, LOI for line of intersection, LOI. Okay, so it's not horizontal there in either view, therefore it's also not a true length in the opposite view. So if it was horizontal, if my LOI was horizontal in my elevation, I would have the true length of it in plan. Or if my line of intersection was a horizontal line in plan, I would see it as a true length in my elevation. Okay, because I'd be looking 90 degrees to it at that rate. Okay, so for example, my line BC is a horizontal line in my plan. Therefore, it's a true length in my elevation. Now, it also happens that it's a horizontal line in my elevation, so it's also a true length in plan. Okay. So the first thing I want to do now is get a view where I am looking 90 degrees to that line of intersection. So I do see it as a true length. So I'm going to come off my plan and I'm going to make a new elevation. So this is my old elevation that comes off my plan. I'm going to make a new elevation coming off my plan, looking 90 degrees to that line of intersection. So I'm looking down along the direction of that pink pencil there. I'm going to get a new elevation. So the first thing I do is I put in an X1, Y1, which is basically just my XY redrawn. And I'm going to actually put it fairly close to this view. I'm actually going to put it right on point D. And we'll have a look at why we do that in 1 second. So I'm putting my new XY right there, my X1, Y1. So X1, Y1. Okay, so that is parallel with my line of intersection there. Therefore, I will be looking 90 degrees to my line of intersection, and I will see that line of intersection as a true length in my new elevation. Okay, so I'm just going to set up a projection line now where they're all going to be 90 degrees. Yeah, so it's important that we project all of our points 90 degrees now to our new XY. So all my points there now are projected 90 degrees to that new XY that I have. Okay, so this is an elevation, the same as this. So whatever heights I have here, I have to have on my new view down here. Okay, so for example, I'll take the height of point D there. So make sure that when you're taking your heights, that you're taking them off a vertical line, we'll say, which will be a projection line from D down to your plan. That's the height there that you're taking, and you're marking it off in your new view. And it's the same then for every single point in the drawing. Okay, so point, take my height, and I mark it from my ground this time up along. So I marked it. So the point of the compass on my new XY, and I just mark off the height, and as soon as I mark it, I label it. That's my point D, so I don't get confused. Next one I'm going with is A. No matter what order you take them in, obviously. So this time I'm following the projection line from A, and I'm marking it from my new XY up along. And B and C are the same height, so I'm going to set it once. So that's the height for B and C. B is up there. Now I will have to extend my projection line a little bit. And C, I can also mark that off. Again, I will have to extend my projection line ever so slightly. Just make sure that you're accurate when you're extending it. That's C and B. Okay, now once I have my new points in my new view, I basically just join them up again. Okay, so ABC B. Of course, BC again should be parallel to my XY because it is in my original view. And again, I'm just going to put in the color on them. ABC is my yellow one. Just a bit of color, just identify them in the different views to make it nice and clear in your solution what you're after doing. Blue one then is ABD. Amateur colouring. And again, my line of intersection is just in red there. Okay, so now what I have is a true length. So TL of the line of intersection. So TL of the LOI. So it's a true length of the line of intersection. Now, when I have a true length of line of intersection, the next thing I need to do is I need to look along the true length. And I should see both planes as an edge view then when I do that. Okay, so I'm just going to look along the true length for this one here. So I'm going to project along my line of intersection. So new XY perpendicular to it. I can just project that up first. I'll just do my projection lines. Use my light. So just do my projection lines up. And we can do an XY then. Okay, or it's actually an X2, Y2. And we're doing that 90 degrees into our projection lines, which is 90 degrees to my line of intersection there. And I'm keeping it nice and close to my view here. I'm making it right on point B. I basically just don't want my view to run off the page. If I had a big enough page, I could of course put my X2, Y2 up here somewhere out of the way. Okay, so that's X2, Y2. Okay, now this time, it's not necessarily height I'm taking distances. So I'm going back 2 views. So this is the view I'm working on. Okay, so we step back 2, so 1, 2. So I'm taking my distance from my X1, Y1 back to my plan. I would have done the same last time for this one. Okay, again, I step back 2 views. So if I was working on this view, I was going 1, 2. So it's my XY up. But this time when I'm going from my X2, Y2 on, it's my X1, Y1 back. Okay, so back 2 views. So I'm working on this one, so it's 1, 2. Okay, now I know D is on the line, which makes it very handy marking it here. Okay, AB. And because our X1, Y1 was parallel to my line AB, those distances are going to be the same up here. So the line AB, which is my line of intersection, will just appear as a dot, which is what it should be as you're looking along it. So that is both for A and B. Okay, so that's point AB. And now all I need is point C. So set my distance for point C. And I mark it onto this view here. Okay, and again, I do need to extend my projection line slightly forward. So let's see just there inside my border. I have is my ABC, is my yellow plane. E is my blue plane. And my line of intersection appears as a dot. Okay, and that gives me a fairly wide dihedral angle. So I'm just going to label it because we need to identify this angle. Sometimes it might ask us to indicate in millimeters what, or in degrees what it is. In this case, we're just going to identify dihedral angle. So you always label as much as you get dihedral angle, but in between ABC and AB. Okay, so that's clearly showing your dihedral angle there between your 2 planes. So important thing again, do your elevation and plan, identify a line of intersection. If it's not a true length in either of those views, we have to find it as a true length. Okay, so we have to make a new XY parallel to it. I could have made my new XY parallel to it in elevation and got an auxiliary plan. Okay, and then I would take my distance from my XY down to my plan instead. I took off my plan, I made an auxiliary elevation. So I took my heights from my elevation and marked them on here. Once I have that, I have my true length of my line of intersection. So that's the view showing the true length. And then we look along our true length. Okay, and the line of intersection then becomes a dot. Okay, a little red dot here. And we draw back in our two planes. Our two planes should appear as an edge view in this case. Okay, and the angle between them then is our dihedral angle.